Hey, what's up guys? It's your boy Magic Max here, and today I'm going to perform a magic trick for you. I'm going to fan out this deck of cards, and I want you to pick any face-up card you see. You got it? Alright. Now, most magicians don't perform this next part of the trick because it's too dangerous, or burning the plastic coating on the cards releases toxic fumes or whatever. But here at Magic Max, we like to take magic to the max. And now, if you'll see, when we take away the logs, was this your card? Now, I'm not going to tell you how I did that magic trick, but for our project, our group decided that we would try and explain a different magic trick by Blaine.
Hey, look, I have a deck of cards. What I want you to do is from in this deck, I want you to try to see one card. Not this one, but look closely. Try to see one inside. Did you get one? Here, I'll do it again. It might have been too quick. Try to see a card inside if you can. Did you see one? You think you did? Don't say it, just hold it in your mind. I know this is not it, but visualize your card right here.
Amazing, right? One of the first questions that comes to mind is, how did he do it? Our group believes that he utilized the subtle yet powerful art of persuasion in order to pull off this magic trick. More specifically, we believe that he took advantage of the brain's visual perception and processing systems in order to pull off this magic trick. One persuasive technique Blaine may have used would be to show the Queen of Spades imperceptibly longer than the rest of the cards, just long enough to influence the spectator's brain into choosing the Queen of Spades, but not long enough to make them aware of what was going on. Our exact question of interest was, does showing a selected card out of a deck of cards imperceptibly longer than the rest of the cards while rapidly flipping through them significantly influence the viewer's tendency to choose that selected card? To answer this question, we set up a set of hypotheses, where the null hypothesis was P2 minus P1 equals 0, and the alternate hypothesis was P2 minus P1 is greater than 0, where P1 is the population proportion of correct random guesses of the viewer's chosen card by the computer, given that all cards are displayed for an equal amount of time of 30 milliseconds. And P2 is the population proportion of correct guesses of the viewer's chosen card by the computer, given that one card is displayed for 200 milliseconds, while the rest of the cards are displayed for 30 milliseconds. The computer's guess is the card which was displayed for 200 milliseconds. Because we are not professional magicians, we created a computer program using the Java programming language, which can flash the faces of cards on the screen for specific amounts of time. When the program is run, the computer's random number generator decides whether the subject receives the control procedure, where all cards are shown for the same amount of time, or the experimental procedure, where one card is shown for a longer instant of time. In the control, the computer chooses a card at random out of all 52 cards in a standard deck, which are then shown for 30 milliseconds in a random order as dictated by the computer's random number generator. Then the subject selects a card. If the computer's randomly chosen card and the subject's inputted card are the same, the trial is recorded as a success, and otherwise as a failure. If the program initially chooses the experimental procedure, the computer's random number generator chooses an integer between 1 and 51, inclusive with uniform probability for all possible values. Then it displays all of the cards in a random order for 30 milliseconds, except for the selected card, which is displayed for 200 milliseconds. If the subject's choice matches the computer's guess, which is the selected card, the trial is recorded as a success. Otherwise, the trial is recorded as a failure. This is an example of the program in action, and, as you can see, the difference in time that the chosen card is displayed is rather subtle. We decided to sample from various students throughout CCA during lunch. While we were collecting data, we had no way of knowing which treatment the subject received, and the subject was never informed of the treatment they were receiving, effectively making this experiment double-blind. In this chart, you can see our results, which makes it pretty clear that the population proportion of correct guesses on the chosen card, given that all cards are displayed for an equal amount of time, is less than the population proportion of correct guesses if the chosen card is displayed for a slightly longer period of time. This difference in proportions is even more clearly illustrated by our stacked bar graphs and table of proportions, which clearly show a difference in the proportion of correct guesses for the experimental and control group. Although we would have liked to perform a two-sample z-test for a difference between proportions, we did not satisfy the large counts condition because we did not observe at least 10 successes from the control group. Because of this, we cannot prove the normality of the sampling distribution of the difference between the two proportions and need to perform a simulation of the differences in proportions as our inference procedure. Using the one categorical variable statistics applet provided by Macmillan Learning, we simulated the distribution of the difference in sample proportion of successes when the observed successes and failures are combined, shuffled, and redistributed into two groups that match the sizes of the original groups. After running the simulation 100,000 times, the number of simulations which yielded a sampling difference of P1 and P2, which was greater than or equal to our observed difference of P2 minus P1 equals 0.344, was 0. Therefore, our simulated p-value is less than 0.00001. Because our p-value of 0.00001 is less than our alpha significance level of 0.05, we reject our null hypothesis. Therefore, we have convincing evidence that the proportion of the population that chose the card when it is displayed longer is larger than the proportion that chose the correct card when all cards are displayed for equal lengths. This signifies that displaying the selected card for a longer period of time does indeed increase the proportion of people who will choose that card. As for the trials in which all cards were displayed for equal length, we observed that the cards people chose varied greatly. Overall, the project yielded very interesting results. This experiment targeted the human perceptions and tested our ability to notice things out of context. In this case, one card is displayed longer than the other cards, and we tried to find out if this difference is picked up by our subjects and whether or not it affected their memory on the cards they saw. The program itself turned out to be a bit troublesome to get working, and we had to spend many hours troubleshooting, which costed us a precious day for data collection. However, once we did get it to work, our results were fairly encouraging. In addition, we managed to obtain a fairly large number of subjects, further increasing our data's credibility. However, with our program, we were only able to see whether or not the computer and the subject chose the same card, and not the actual cards. An improvement on this study would be to record the card which the spectator and the computer chose in the data, so that a follow-up analysis can be done. An additional improvement to this study would be to obtain a sample large enough to satisfy the conditions for a two-sample z-test for a difference in proportions. Thank you for watching, and I hope you enjoyed.